Welcome to Mission Control Houston at NASA's Johnson Space Center, where we are live preparing for the arrival of Northrop Grumman's 21st cargo resupply mission to the International Space Station. For our coverage today, first up, NASA astronaut Matthew Dominic will use the station's robotic arm to grapple or grasp the Cygnus cargo spacecraft, with NASA astronaut Jeanette Epps acting as his backup. We will take a brief break, and then we will be back on air to cover the final installation of Cygnus to the station, and that's going to be performed by the mission control team here in Houston. That initial capture by the NASA astronauts is currently scheduled to take place at approximately 3:10 a.m. Eastern Time, 2:10 a.m. Central Time. Thank you for joining us. This is Mission Control Houston. And we have a tally-ho with the vehicle here in Mission Control Houston. This is a cargo spacecraft that launched at 11:02 a.m. Eastern Time, 10:02 a.m. Central Time on Sunday.
Houston Station, Space Ground 2. Cygnus is in sight.
Houston copies. Tally-ho.
And you just heard NASA astronaut Jeanette Epps confirm that also on station, they can see the Cygnus cargo spacecraft in view. That's what that tally-ho means. We are entering an orbital sunrise, so we should get better views here of the vehicle shortly. About 15 minutes ago, the team successfully conducted the ADV-3 burn. That's the approach initiation burn. It's going to allow Cygnus to position itself directly below the station. Coming up here in just a few minutes is going to be the ADV-4 burn. This is going to be a burn that changes the speed and direction of Cygnus. That's going to have it rendezvous to a 250-meter hold position. That's going to be our next milestone that we're looking for. Our capture is scheduled for that 3:10 a.m. Eastern Time, 2:10 a.m. Central Time. And on board the International Space Station, we have NASA astronauts Matthew Dominic and Jeanette Epps, currently in the space station's cupola at the Robotics workstation. And they're going to be using the controls in there to maneuver the space station's robotic arm to actually capture the Cygnus spacecraft. You heard NASA astronaut Jeanette Epps a little bit ago communicating with the mission control team here in Houston.
Station Houston on Spacecraft 2. Reminder for all ISS crew that Cygnus trotter viewing constraints now apply. To prevent potential eye damage during Cygnus approach, cease using binoculars and DSLR cameras with uncovered viewfinders.
Station copies.
We are a little under 90 seconds from that next burn that's going to position us at that 250-meter hold point. This is Northrop Grumman's 10th contracted resupply mission for NASA under the Commercial Resupply Service, or CRS-2 contract. It's their 21st total resupply mission in total. There is no crew on board. This is cargo that is arriving, over 8,400 pounds of it, including important experiments, hardware, and supplies to the crew living and working in space right now. Here on your screen, you can see some statistics of what we have on Cygnus. We have crew supplies, those science investigations, also some spacewalk equipment, vehicle hardware, and other computer resources, putting us in at over 8,400 pounds. For some more statistics about our launch, this vehicle launched aboard a SpaceX Falcon 9 rocket from Launch Complex 40 at Cape Canaveral Space Force Station in Florida. And that AD4 burn is underway. We are currently in joint operations with Northrop Grumman's Mission Control. They are located in Dulles, Virginia, and NASA, we are here in Mission Control, Houston. Now at that 250-meter hold point, that's really important because it's going to then bring us into what's called the keep-out sphere. So the approach ellipsoid and the keep-out sphere are two invisible lines around the station. They are monitored by the flight controllers and they are used to govern vehicles approaching and leaving the station. We do currently have a expected video outage. We are not expected to have this during our capture and installation, so we are expected to have views during that. As the space station flies around the Earth, our communication paths need to transfer between satellites, so we are just in one of these handover periods right now. While we're waiting on our video to resume, you can see live views of mission control here in Houston. Our flight director today is Elias Mirmo. He's part of the class of the 2022 flight directors. He joined NASA in 2008 in the Flight Operation Directorate's Mission Systems Division, working on Mission Control Center systems and information technology infrastructure. He became a communication radio frequency onboard network utilization specialist in 2010, logged more than 2,000 hours at console in support of the International Space Station expeditions 32 through 50. He has also served as lead of the Exploration Flight Dynamics and Operations Group, which is responsible for the training and certification of flight dynamics officers for Artemis missions. He was raised in Naples, Florida, graduated from the University of Central Florida in Orlando with a Bachelor of Science degree in computer science. As in the Apollo days, the flight director here in Mission Control Houston has absolute authority and responsibility over the success of this mission. The voice you will actually hear going out on our loops is going to be our Capcom position. They are actually the voice link between the mission control team here in Houston and the crew on board the station. Today, the voice of that Capcom is David Brenna. The space station is currently flying over Ethiopia, and that previous burn that we did, the ADV-3, that approach initiation burn, allowed Cygnus to position itself directly below the station. So now we are onto that ADV-4 burn. It's going to have it rendezvous to that 250-meter hold position. Teams are going to pull go, no go for the vehicle to enter into that keep out sphere. So right now we are in the approach ellipsoid. It allows for 24 hours of safety if the vehicle happened to lose control. Once we're in that keep out sphere, it allows for 4 orbits of safety. So it's much closer to the space station. It's also going to give the crew on station command capabilities, so they would be able to initiate an abort if necessary. However, all is looking good. We are still on track for that approximate 3:10 a.m. Eastern Time, 2:10 a.m. Central Time capture. "250 meters is not the only place that Cygnus is going to hold today. We're also going to hold at the 30-meter point. And then finally, we're going to move in until about we're 10 meters away from the station. At that point, NASA astronaut Matthew Dominic is going to bring the space station's robotic arm to the spacecraft and actually capture it. At the end of the robotic arm is the lead, also known as the latching end effector, essentially the hand of the arm. Inside of that, there are those latches and snares that are going to grab onto the target on Cygnus. We do have a camera on the end of the lead, so we are expected to get views of when Dominic actually makes that final grasping of the spacecraft. Cygnus is officially under 300 meters away from the space station. While we are waiting for it to rendezvous to that 250-meter hold point, we do have some recap footage of Cygnus's launch that we can take a look at. If you are just joining us, Northrop Grumman's Cygnus spacecraft is continuing on its way to the International Space Station. Following a launch, you see recap footage here. It launched at 11:02 a.m. Eastern Time, August 4th, on a SpaceX Falcon 9 rocket from the SpaceX Launch Complex 40 at Cape Canaveral Space Force Station in Florida. The spacecraft completed the deployment of its 2 solar arrays at 2:21 p.m. the same day. Shortly after launch on Sunday, the spacecraft performed as designed by canceling a scheduled engine burn due to a slightly low initial pressure reading that was flagged by the Cygnus onboard detection system. However, engineers at Northrop Grumman's Mission Control Center in Dulles, Virginia, evaluated the pressure reading, confirmed it was acceptable, and reworked the burn plan so that we are arriving at the space station at our original expected time, that 3:10 a.m. Eastern Time, 2:10 a.m. Central Time. Cygnus was developed by Northrop Grumman and is a part of NASA's Commercial Resupply Services program for the International Space Station. It's an unpiloted, fully autonomous spacecraft, can be monitored and controlled by astronauts on board the International Space Station, and also, of course, Northrop Grumman's mission control team in Dulles, Virginia. There are 3 main elements of the spacecraft. We have a service module, which handles its power, propulsion, and navigation, the pressurized cargo module, where those 8,400 pounds of important cargo is located, and then also a berthing mechanism that is going to allow it to be installed to the space station. Cygnus is expected to remain docked to the station for about 6 months. At the end of its mission, It is going to dispose of trash and other obsolete equipment by deorbiting and safely burning up over the Pacific Ocean. So this is Northrop Grumman's 21st cargo resupply mission to the International Space Station. This Cygnus also has a special name. It is a tradition to name Cygnus after a pioneer in space exploration who is deceased. This cargo spacecraft is named the SS Dick Scobee. It is named in memory of NASA astronaut Richard Dick Scobee. He was a United States Air Force pilot and Vietnam veteran. He was selected as an astronaut in 1978 and chosen as a pilot of the STS-41C mission, where he logged 168 hours in space. In 1986, he served as commander of the Challenger spacecraft for the STS-51L mission, where he and his 6 crewmates lost their lives shortly after launch. Scobee was posthumously awarded the Congressional Space Medal of Honor in 2004 by former President George Bush. We're coming up at just about a minute until Cygnus reaches that 250-meter hold point. Again, those teams are going to poll go, no go for it to proceed to its next milestone. It's going to bring it inside that keep out sphere. And next, we are going to be holding at the 30-meter point away from the station. Cygnus is arriving at that 250-meter hold point, and that go, no go poll is going to begin shortly.
Houston, station on 2 for CSACP.
We are with you on 2, TC, go ahead.
NASA astronaut Jeanette Epps is there on station assisting NASA astronaut Matthew Dominic with Cygnus's grappling today. While he focuses on the controls, you might hear her call down more often to the mission control teams here in Houston.
With you on 2, Tracy, go ahead. Sorry, we're tracking through some blockers there.
Yeah, no problem. Hey, Alec brought me a CSACP that had a battery fail, so I just wanted to make you guys aware and get the deets on the spare batteries, and if I had to go to just change that out.
Hey, Tracy, could we get a serial number from that CSACP?
Why, sure. Stand by. It's 1071.
Station Houston on Spacer Ground 2. Confirm Cygnus 250-meter hold per step 2 and 1.102.
Copy. Station copy.
You heard a little bit ago the voice of NASA astronaut Tracy Dyson call down. There are still other activities going on board the station. However, they might move those over to other loops once we get closer to the grappling of Cygnus.
Houston station on Space Ground 2 for step 2. We can verify that the gray quarter is displayed on the overlay, and we can verify that the PCS Cygnus command panel LED is as shown in step 1.102 for the hold. And we have a good frame count, and the pry range is 251.
Houston copies all.
And Houston for a block Bravo. And for a block Bravo, we can confirm that the light is inside the corridor, the vehicle size matches, the light is offset about a half vehicle width starboard, and then the circle is about 1.5 vehicle width port of the corridor center. And that's in monitor 1. In monitor 3, we have almost the same, except that the light is within the circle.
And Jeanette, thanks. We copy all.
So this is the view inside the cupola that NASA astronauts Matthew Dominic and Jeanette Epps are looking at. A little bit ago, she was reading out some data from this to the teams here in Mission Control. Want to point your attention to the bottom right of the screen. You can see VV to ISS. That's visiting vehicle to the International Space Station, and you can see we are at that 250 meters. At that robotics workstation, of course, it's in the cupola. That's that area, iconic area of the International Space Station.
Station Houston on Space to Ground 2. Cygnus and ISS are configured for approach inside the keep-out sphere. Expect approach to resume shortly and stand by for the Cygnus PCS command checkout.
Mission copy.
And you just heard, we are a go for Cygnus to continue its approach to the International Space Station. It's going to enter that keep-out sphere. Our next milestone is going to be that 30-meter hold point. Inside the cupola at that robotics workstation are NASA astronauts Matthew Dominic and NASA astronaut Jeanette Epps. Epps is serving as the second set of eyes. Dominic is going to...
Station Houston on 2. Cygnus has resumed approach. Go for Cygnus PCS command checkout. Hold arm for step 3 and 1.102.
Station copies and in work.
There are a series of steps that Epps and Dominic are going to move through together. You can hear them calling out those steps back and forth with mission control as Cygnus approaches. At the robotics workstation, they have 3 different monitors. They can also change camera views to get different perspectives of Cygnus. And there you can see in the bottom right that our range has decreased from 250 and is continuing to go down as Cygnus gets closer to the station. Now to actually grapple or grasp Cygnus today, they're going to be using the space station's robotic arm. Again, we just entered one of those expected loss of signals as the data is handed over to those different satellites. To grapple Cygnus today, Dominic is going to be using the space station's robotic arm. This is
Houston, how copy?
Jeanette, we're with you on 2. If you called, I did not get your last.
Okay, the hold command is armed.
Okay, Jeanette, we copy and hold arm is confirmed. You are go for Cygnus PCS command checkout disarm for step 4 and 1.102.
Copy, step 4 in work.
This robotic arm is also known as the Canadarm2 or the SSRMS. That's the Space Station Remote Manipulator System. It's part of the Canadian Space Agency's contribution to the International Space Station. It's 57.7 feet long when it's fully extended, and it was extensively used in the assembly of the space station. It lends a helping hand to perform station maintenance, move supplies, equipment, and even astronauts during spacewalks.
Houston Station on 2, the whole command is disarmed.
Jeanette, we copy. Cygnus PCS command checkout was successful. Begin monitoring approach from 250 meters per step 5 and 1.102.
Copy, step 5 in work.
Now less than 200 meters from the International Space Station. Today we will get to see also how the robotic arm performs these cosmic catches by grappling visiting vehicles and then enabling them to be installed to the International Space Station. When NASA astronaut Jeanette Epps is confirming working through these steps, here in Mission Control Houston, the ICE position is confirming that data on our side. ICE is the Integration Systems Engineer. They're responsible for monitoring key systems and operations of the visiting vehicles approaching and eventually being installed or mating to the U.S. segment of the International Space Station. Our ICE console position is Lisa Malam.
Houston Station on 2 for a block Bravo.
With you on 2.
Okay, the light is in the corridor. Vehicle size matches. And this is for monitor 1. The light is slightly offset starboard from the circle. And then the circle is slightly starboard and slightly aft in monitor 1. And for monitor 3, the light is in the corridor, the vehicle size matches, the light is in the circle, and the circle is slightly offset starboard of the center of the corridor.
Okay, Jeanette, we copy all, no concerns. Cygnus is inside the 200-meter keep-out sphere. Crew now has the authority to issue an abort if no comm with Houston and the light is outside the corridor. Also a reminder that for TRIDAR within 40 meters, this is for all the crew to prevent potential eye damage during Cygnus approach due to TRIDAR. Cease viewing Cygnus from all windows except cupola once we get to 40.
And station copies all.
NASA astronaut Jeanette Epps walking through some of the data you just saw, or you do see on your screen right now. As Cygnus moves toward that 30-meter hold point, we're right at 150 meters. We will continue to hear any audio that comes down from the crew to the mission control team here in Houston. In the meantime, while we're waiting on Cygnus to reach that next milestone, let's talk about some of the important research that is on board. First up is an experiment to understand gravitational effects on filtration systems. The packed bead reactor experiment water recovery series investigates how gravity affects two-phase flow or simultaneous movement of gas and liquid through porous media. Teams will evaluate 8 different test articles representing components found in the space station's water processor or urine processor to understand two-phase flows for both liquid and gas in microgravity. Packed bed reactors are structures that use packing of objects, usually pellet-like catalysts, You can see an image in the bottom right of your screen of an example of that. These are various shapes and materials to increase contact between different phases of fluids. Systems are used for a variety of applications, such as water recovery, thermal management, and fuel cells, and the experiment develops a set of guidelines and tools to optimize their design and operation for water filtration and other systems in microgravity and eventually on the Moon and Mars. Insights from the investigation could also lead to improvements in this technology for applications on Earth, such as water purification and heating and cooling systems. Next up, balloon sounds in space. This is demonstrations as part of NASA's Next Gen STEM. STEM stands for Science, Technology, Engineering, and Mathematics. This is a project from that program where these projects are performed and recorded by astronauts on the space station. Each NASA demonstration illustrates a different scientific concept and includes resources to help teachers further explore the topics with their students. So for this one, astronauts are going to demonstrate centripetal force on the space station using a penny, a hex nut, and 2 clear balloons. The penny and the hex nut are whirled inside of the inflated balloon to compare the sounds made in a microgravity environment. Understanding spaceflight effects on DNA is extremely important. Next up is an ESA experiment from the European Space Agency. It's an investigation explores how spaceflight affects DNA.
Station Houston on 2 for Tracy and CSACP.
Go ahead for CSACP.
Hey, Tracy, we have a procedure reference and the stowage locations for you. The procedure is 2.5.760 for a CSACP battery changeout, and I have a stowage location when you're ready to copy.
Ready, copy.
All right, that is Lab 1, Overhead 5, Alpha 2. Should be in a 24 by 24 Ziploc. And if you could please report the serial number of the new battery.
Okay, I'll get that in work. Thanks.
Thank you.
Back to our science here on this experiment is investigating those DNA repair mechanisms in microscopic organisms. These tiny but complex organisms are known for their ability to withstand harsh conditions, including radiation doses 100 times higher than what human cells can survive. Researchers are going to culture them in an incubator facility on the space station. After they become exposed to microgravity conditions.
What should I do with the failed CSACP battery? It was actually saying on the display battery failed or something to that effect.
And Tracy, we copied your question. We're thinking about it and we're checking. We'll have to get back to you.
Sure.
NASA astronaut Tracy Dyson working with mission control teams here in Houston on a battery swap. This is a separate activity from our Cygnus arrival today. Finishing out on this experiment, so after those organisms are exposed to the microgravity conditions, it's going to provide insights into how space flights will affect their ability to repair sections of damaged DNA. This could improve our general understanding of DNA damage and repair mechanisms, also for applications on Earth.
Station Houston on Space Ground 2 for T2. We currently see T2 is in use. Just a reminder that there's a no T2 exercise constraint during Cygnus capture.
Yeah, we copy it as now not in use, so we're good.
Houston copies.
You just heard Capcom here in Houston call up to the crew. The astronauts on board have to stop any daily exercises during Cygnus's arrival. This is to ensure no impactful vibrations or any movements of the station occur. Extremely important, especially while Dominic is operating that robotic arm to grapple Cygnus. Today, you might also hear a call out on the loop that DSATs are inhibited. So these are automatic thrusters on board the space station that keep it in its correct position. So we don't want those to go off and also interrupt the capture or installation of Cygnus. So throughout our coverage today, you might hear that come out over the loops as well. We are about less than 1 hour from that anticipated capture time of 3:10 a.m. Eastern Time, 2:10 a.m. Central Time. The preference is for Cygnus to be captured during an orbital daytime. We are going to be entering an orbital nighttime here shortly, but remember the space station goes through about 16 orbits in a 24-hour period. There are backup capture opportunities planned for today as well. So if for some reason that first capture attempt fails, we do have backup attempts. However, that first one is still on target for the 3:10 a.m. Eastern Time, 2:10 a.m. Central Time. So again, we do want acceptable lighting conditions for that grappling of Cygnus. So once we enter back from this upcoming orbital nighttime, that is when NASA astronaut Matthew Dominic will be able to utilize the robotic arm to grasp Cygnus. You are looking at live views of the Northrop Grumman 21st cargo resupply mission to the International Space Station, now less than 60 meters away. Once it arrives at that next 30-meter hold point, teams will perform a go, no-go for it to approach the station. However, again, we are entering that orbital nighttime, so we are going to wait until we are back in an orbital daytime for that capture to proceed. There is no crew on board Cygnus today. It is flying autonomously. Northrop Grumman's engineers in their flight control room in Dulles, Virginia, are able to send those commands to Cygnus. On board is over 8,400 pounds of important experiments, hardware, and supplies that's going to be delivered to the crew living and working in space right now. This is a contracted resupply mission for NASA under the Commercial Resupply Services 2 contract. NASA's commercial space program has enabled successful partnerships with American companies to resupply the International Space Station. Through this strategy, NASA is delivering on its goal of achieving safe, reliable, and cost-effective access to and from the International Space Station. On our arrival process today, first Cygnus is going to maneuver close to the International Space Station, where the robotic arm will grapple it. Next up, teams here in Mission Control Houston are going to actually then install it on the space station. It's going to be going on the nadir port, or the Earth-facing port, of the Unity module. After NASA astronaut Matthew Dominic grapples the Cygnus spacecraft, we are going to take a brief break, and then we will be back on air for that installation of the spacecraft to the station. Teams are going to begin polling here shortly for that go, no go to advance beyond that 30-meter hold point. Right now, the vehicle is inside that keep out sphere, the invisible line around the station. The crew also now has on-orbit command capabilities in case something were to go wrong. They can execute an abort on their side. And you can see our sunlight begin to fade as we enter that orbital nighttime. As our sunlight starts to fade, we should still be able to keep those views of Cygnus's navigation lights. The other dots, the very tiny dots you're seeing on your screen, those are actually dead pixels from radiation exposure from the cameras on board the International Space Station. Just like on a boat, the red navigation light indicates the port side of the spacecraft, and the green light indicates the starboard side.
Station Houston on Space Ground 2. Confirm 30-meter hold and set up for capture per step 6 in 1.102.
Station copies. We can verify that the pry range is 30 meters.
Teams are conducting that final go, no go. The go, no go for the final approach. You can see on your screen here a live view. This is what NASA astronauts Matthew Dominic and Jeanette Epps are looking at on board station right now. You can see they just confirmed in that bottom right screen that Cygnus is holding at that 30-meter hold point. During our coverage today, you're going to hear us refer to the installation of Cygnus as berthing. So this is actually different than docking. Docking is different in its interface. Docking allows for the vehicle to push in and uses hooks to secure its position. Those docking ports are smaller, but allow for a lot of flexibility. In comparison, berthing is like installing two spacecrafts together. It's similar to how the International Space Station was originally mated together. So the opening is a lot wider. Benefit here is it can take larger payloads through that common berthing mechanisms. Once our NASA astronauts use that robotic arm to grapple it, we're going to take a brief break. We'll be back on air for the installation coverage, and the installation coverage is actually going to occur from the ground, from the robotics or robo position here in Mission Control Houston. ROBO stands for the Robotics Operations Systems Officer. They are responsible for the mobile servicing system operations. They manage the external and internal MSS systems and related task and arm trajectories. On console today doing that installation coverage is Casey Chen. He is going to take control of the arm and he will conduct that final berthing to the station. It's going to drive in those latches and hooks that is going to securely berth it to that nadir port. That's the Earth-facing port of the Unity module. But first up, we are going to grapple or grasp Cygnus, and that's going to be done on board the station by NASA astronaut Matthew Dominic. NASA astronaut Jeanette Epps is acting as his backup. He's going to be using a joystick controller to do that. Part of his training, well, all of the astronauts' training that occurs here at Johnson Space Center in Houston is actually using a simulator to practice this. They also practiced ahead of today's arrival. They practiced that on board as well. Flight controllers here in Mission Control Houston have detailed sets of procedures, different actions, contingency plans they can take. We're reviewing all of those right now. ICE, the Integration Systems Engineer, is responsible for monitoring key systems and operations of the visiting vehicles approaching and mating to the U.S. segment of the International Space Station. We also discussed Robo's responsibilities for today. So we are at that 30-meter hold point. Everything is proceeding nominally. However, we do have to wait until we are out of that orbital nighttime in order to proceed with the capture of Cygnus. It's a tradition to name a Cygnus spacecraft after a pioneer in space exploration who is deceased. This is Northrop Grumman's 21st cargo resupply mission to the International Space Station, and it is named in memory of NASA astronaut Richard Dick Scobee. He was a United States Air Force pilot and Vietnam veteran. He was selected as an astronaut in 1978 and chosen as a pilot of the STS-41C mission, where he logged 168 hours in space. In 1986, he served as commander of the Challenger spacecraft for the STS-51L mission.
Houston, station on 2. The crew is ready for Cygnus approach to the capture point.
Houston copies, and we'll be waiting until about 0648 to depart 30 meters.
Copy that.
NASA astronaut Jeanette Epps on board, letting the ground teams on Earth know that they are ready to receive Cygnus. However, because we are in that orbital daytime, we are still holding at that 30-meter mark. Estimating about 10 more minutes here before we depart for that 10-meter capture point. Back to Scobee. He was commander of the Challenger spacecraft for the STS-51L mission when he and his 6 crewmates lost their lives shortly after launch. He was posthumously awarded the Congressional Space Medal of Honor in 2004 by former President George W. Bush. On board Cygnus today is over 8,400 pounds of cargo. On that is important science investigations, but also is hardware, crew supplies, and other equipment. The International Space Station Rollout Solar Array, or IROSA Modification Kit 8, is on board. This upgrade kit consists of power cables and large structural components such as a backbone, mounting brackets, and 2 sets of struts. This kit will support the installation of the 8th set of rollout solar arrays located on the S6 truss segment of the orbiting laboratory. That's expected to happen in 2025. The new arrays are designed to augment the station's original solar arrays, which have degraded over time. These replacement solar arrays are installed on top of the existing solar arrays to provide a net increase in power. Each array generates more than 20 kilowatts of power. Also on board is a plant habitat environmental control system. This is a component of the advanced plant habitat, and it controls temperature, humidity, and airflow in the growth chamber. It's an enclosed, fully automated plant growth facility that will conduct plant bioscience research in orbit for up to 135 days and complete at least 1 year of continuous operation without maintenance. And just to clarify on that IROSA modification kit, it is just the kit that is arriving on Cygnus today. The upgrade kit consists of power cables, large structural components such as the backbone mounting brackets, and 2 sets of struts. It's going to support the installation of the actual solar arrays. So just on Cygnus Day, it's just the modification kit. For a brief recap of Cygnus's journey to the International Space Station, it launched at 11:02 a.m. Eastern Time on August 4th on a SpaceX Falcon 9 rocket from the Space Launch Complex 40 at Cape Canaveral Space Force Station in Florida. We have another expected loss of signal occurring right now. Again, we are expected to have those live views for the actual capture of Cygnus. In the meantime, you are looking at live views of mission control here in Houston. Elias Mirmo is our flight director today. He is part of the class of the 2022 flight directors. He joined NASA in 2008 in the Flight Operation Directorate's Mission Systems Division, working on Mission Control Center systems and information technology infrastructure. He was raised in Naples, Florida, graduated from the University of Central Florida in Orlando with a Bachelor of Science degree in computer science. Today, he is leading the flight control team. He's responsible for real-time crew safety, vehicle safety, and mission success. As in the Apollo era, the flight director has ultimate decision authority and responsibility for the mission. However, it's not his voice you've been hearing on the loops talking with the crew. That's been actually the Capcom position, or capsule communicator. So on your screen, the second row of desks from the back on the left, that first desk is going to be your flight director. Next to him is going to be our Capcom. That's the capsule communicator, the voice link between the crew and the flight control team. Here you can see a closer view there. So the one in the middle is our Capcom, and then our flight director is the bottom right. And our Capcom today is David Brenna. He's the voice that you are hearing talking up to the crew on board the International Space Station.
Station Houston on Space to Ground 2. Cygnus is ready to proceed to the capture point. Expect approach to resume shortly.
Station copies.
And we are go to proceed to that capture point. It's going to be about 10 meters from the space station. Again, though, we are going to wait until we are in an orbital daytime for NASA astronaut Matthew Dominic to start moving that robotic arm towards Cygnus. At the end of the arm is the LEE, L-E-E, latching end effector. It can be thought of as the hand of the arm, and inside are those latches and snares that are going to grab onto a target on Cygnus. That's going to be a target that Dominic has practiced with simulators both here at Johnson Space Center in Houston and also on board the International Space Station. Dominic is a Colorado native. He earned a Bachelor of Science in Electrical Engineering from the University of San Diego and a Master of Science degree in Systems Engineering from the Naval Postgraduate School.
Station Houston on Space to Ground 2. Cygnus has resumed approach to the capture point. Monitor approach within 30 meters per step 7 in 1.102.
Station copies. We see the prior range decreasing, and for a block Bravo, the light is, for both monitors, the light is within the corridor, the vehicle size matches, the light is in the circle, and the circle is centered in the corridor.
Houston copies, good block Bravo.
That was the voice of NASA astronaut Jeanette Epps. She is serving as the backup for Dominic today. While he focuses on the controllers, we will probably hear her voice quite often, taking over the task of talking with the mission control teams here in Houston. You can see her screen that she is looking at right now live on board the International Space Station. Epps was selected by NASA in 2009 as an astronaut. She is a New York native and was a NASA fellow during graduate school. She's authored several journal and conference articles describing her research. She also worked for Ford Motor Company, where she received both a provisional patent and a U.S. patent for her research. From there, she joined the Central Intelligence Agency for 7 years, working as a technical intelligence officer before becoming an astronaut. She has a Bachelor of Science in Physics, a Master of Science, and a Doctorate of Philosophy in Aerospace Engineering. That one came from the University of Maryland. Her graduate research involved extensive testing of composite swept-tip beams, comparative analysis of analytical models, and experimental data for shape memory alloys, and the application of shape memory alloy actuators for tracking helicopter rotor blades. Both NASA astronaut Matthew Dominic and Jeanette Epps are part of Crew 8. They launched on March 4th of this year to the International Space Station. Here is a picture of everyone that's currently on board the station right now. We have Commander Oleg Kononenko, Nikolai Chub, NASA astronauts Tracy Dyson, NASA astronaut Mike Barrett, NASA astronaut Matthew Dominic, NASA astronaut Jeanette Epps. We have Alexander Grobenkin, and also our Starliner astronauts, Sunny Williams and Butch Wilmore. Cygnus is less than 17 meters from the International Space Station. Although it is an orbital nighttime, Cygnus is flying autonomously, so it does not need the sunlight to reach this next capture point. However, we do need that. We are still targeting that 2 a.m. Central Time, 3:10 a.m. Eastern Time capture of Cygnus. Once Cygnus arrives at that about 10-meter arrival point, teams are going to give that final go, no go for capture. NASA astronaut Matthew Dominic is prime to utilize the controllers aboard the International Space Station, that robotic arm to grapple Cygnus. Both he and NASA astronaut Jeanette Epps are currently inside the space station's cupola at the robotic workstation.
Station Houston on 2. Confirm capture point hold per step 8 in 1.102.
Station copies, and we see the visiting vehicle mode as CP hold.
Houston copies.
And we have reached that hold point of Cygnus. You can see on your screen just how close it is. In the bottom right of the screen, it's a little hard to see, but that is the space station's robotic arm right there. Right now, we are just waiting on those optimal lighting conditions, and teams are polling for that go, no go for capture right now.
Houston in blockade. We are good with everything except the sun is going to be right in our face for the next maybe 5 minutes as the sunrise happens, and then we should be good to go after that.
Hey, Matt, we copy. No concerns here. Waiting until you're good with lighting. And stand by for capture.
Yeah, we are holding. We are now proceeding into step 4. We have the cupola windows open the forward side for situational awareness, and the sun's pretty bright, so we'll let the sun come up a little bit, and then we should be go after that, if you concur.
We copy.
A bright but beautiful sunrise as the International Space Station is flying over the South Atlantic Ocean. Once we receive those optimal lighting conditions, the crew on board is going to receive that final go for capture, so we are just waiting for that.
Station Houston on 2. We are go for Cygnus capture sequence, step 4 in 1.110. Cygnus capture. Begin monitoring the backway cue card as soon as you're ready.
Station copies, and we'll let you know when we're ready.
Here on your screen, you can see on the left, that is the space station's robotic arm that NASA astronaut Matthew Dominic is going to be controlling. He's going to push that into Cygnus and grapple onto it. NASA astronaut Jeanette Epps is assisting him, serving as his second set of eyes. You'll also hear her call down to the crew in mission control. The astronauts do have the go from ground teams here on Earth to proceed with capture.
Houston Station on Space Ground 2. We're in step 4.2, and we're waiting to capture for lighting conditions.
Houston copies.
The crew is standing by for better lighting conditions. We did just recently exit that orbital nighttime and are into that orbital daytime right now. This is a live view of Cygnus and the robotic arm on the left. The robotic arm has not started to move yet. Again, the crew is waiting for better lighting conditions. At the end of the robotic arm is the lead. That's the latching end effector, the hand of the arm. There are latches and snares that are going to grab onto the target. NASA astronaut Matthew Dominic is going to maneuver that arm so that it can grab onto the
Station on 2. We're ready with the lighting, and we can complete step 4.2 on your go.
Houston copies. Go for it.
Work.
NASA astronaut Jeanette Epps on board the space station confirmed that they are good to proceed with capture. However, the robotic arm is not currently moving yet. You are seeing live views of that capture on your screen right now. And we have confirmed movement. The crew is pushing in the robotic arm to Cygnus. We do have a camera at the end of that lee, or the latching end effector. You're seeing live views now as NASA astronaut Matthew Dominic pushes in the robotic arm to Cygnus. The circle towards the bottom is actually the grapple target. Dominic is going to be aiming for that horizontal bar just above it. The fixtures on the robotic arm are going to engage with that circular pinwheel shape that is directly below the horizontal bar. Two meters away. One meter. 2:11 a.m. Central Time, 3:11 a.m. Eastern Time. While the space station flew over the South Atlantic Ocean, Northrop Grumman's 21st commercial resupply service mission was successfully captured at the hands of NASA astronaut Matthew Dominic. The Cygnus cargo spacecraft, as you see on your screen, is now securely attached to the space station's robotic arm. Next up is going to be the installation of the Cygnus spacecraft. That is actually going to be done by the ground team here in Mission Control Houston. For now, NASA astronauts Matthew Dominic and Jeanette Epps are relieved from their duties. Will go on to their tasks for the day. We are going to take a brief break on our coverage, and we will be back for that installation.
Houston Station on 2, the Cygnus capture is complete.
Go for Cygnus post-capture reconfiguration. You know, the space station brings a lot of visiting vehicles aboard, and we make it seem regular, but there's nothing regular about making one space station connect to another. It's incredible every single time. Welcome aboard the space station, Dick Scobee.
Houston copies all and concurs. This has been an incredible effort from both our Northrop Grumman and NASA teams, and all the way from mission planning and preparation leading up to launch, and especially over the past 48 hours of mission execution. Outstanding work today to y'all, and congrats on successfully capturing the 21st Cygnus and 50th visiting vehicle to the International Space Station. Why don't y'all go celebrate with some ice cream?
Did you say 50th? It's incredible. What an incredible group of teams from around the planet that make this happen every single time. Thank you, guys.
You heard wonderful congratulatory remarks. Northrop Grumman's Cygnus spacecraft supporting the Northrop Grumman's 21st commercial resupply service mission to the International Space Station has been successfully grappled at the hands of NASA astronaut Matthew Dominic, with NASA astronaut Jeanette Epps serving as his backup. 2:11 a.m. Central Time, 3:11 a.m. Eastern Time is our official time of capture. We are going to take a brief break. We will be back on air for our installation coverage at 3:30 a.m. Central Time, 4:30 a.m. Eastern Time. Thank you for joining us today. This is Mission Control Houston.